All right, so we're going to be looking at doing a calculation with the difference of random variables. So let's look at this problem here. So we're going to look at problem 63, O2 emissions. So the amount of nitrogen oxides, NOx, present in the exhaust of a particular type of car varies from car to car according to a normal distribution with a mean of 1.4 grams per mile and standard deviation of 0.3 grams per mile. Two randomly selected cars of this type are tested. One has 1.1 grams per mile of nitrous oxide, and the other has 1.9 grams per mile. The test station attendant finds this difference in emissions between two similar cars surprising. If the nitrous oxide levels for two randomly chosen cars of this type are independent, find the probability that this difference is at least as large as the value that attendant observed. Okay, so that's a lot going on there, but let's break it down into math. That's going to make our lives easier, believe it or not. So we have a normal distribution, so it's right n of where the mean is 1.4. So the mean of x, let's make it x 1.4, and standard deviation of x of 0.3. X is going to be, it's going to be the amount of nitrous oxide in grams per mile for a randomly selected car. Now, they tested two randomly selected cars, and they had two different values of x. So let's say x1, the first car, had a 1.1 nitrous oxide level. The other car, x2, had a 1.9 nitrous oxide level. So those are the two values of x. Now the attendants, like, whoa, these are two different. Proportionally they do look pretty different. It seems like almost twice as down. But anyways, so what's going on here? They're supposed to be on average 1.4, but you got these about 0.8 away. So if this is like a big deal, then we want to find that the probability of this occurring to be very small. In other words, the probability that you're going to get a difference of at least 0.8 grams per mile is like 1% or something, then you're gonna be like, yeah, something shady is going on. If it's like 10%, 20%, then you're gonna be like, I guess it's not that big of a deal. So what we're actually looking at is a different type of variable, with another variable, and we'll call it, we can call it T, but we'll call it, we'll just call it D because it's the difference, where D is going to be the difference of two randomly selected variables. So D will be just x1 minus x2, the difference. Now, you can do x2 minus x1, doesn't matter. Just make sure you interpret it correctly. So if D is the difference of two randomly selected variables, then, we did 1.1 minus 1.9 in this case. And you got, negative 0.8. Just for that case, we got a value of negative 0.8 for D. But we have to see what the distribution of D is. So we want to find the mean of D. Let me write it over here, actually. The mean of D and the standard deviation of D. Now, if D is equal to x1 minus x2, the mean of D will just be the mean of x1 minus the mean of x2. And x1 and x2 have the same distribution. They both come from this. They both have a mean of 1.4. So their mean difference is 0. Or the mean difference is 0. And that makes sense because you're basically selecting from the same, distribution. And if they're kind of expect them to be 1.4 usually, yeah, then they're all going to be the same, you would think, on average. So the mean difference of 0 makes sense. Now we need to find the standard deviation of D, but we can't figure it out simply by finding, standard deviations and subtracting them. We're going to need to find the variance of D and then take the square root. Because if you find the variance, you can use this formula. The variance of D will be the variance of x1 plus the variance of x2. Oops, variance of x1. Variance of x1 What's the variance of x2? Now, yeah, remember that it's kind of weird. It's kind of counterintuitive because you're like, why don't you subtract them? But it's whether you add two values or you subtract them, the variance of their differences or sums are going to be the sums of their variances. Because remember, it's a measure of spread. I explained this more in a different video, but for now, let's just go with it. But keep in mind, you always have this formula sheet that you can use. It's the one I have. Anyways, going back to this, let's calculate what we got. So we have this that the standard deviation of x is 0.3, so the variance will be 0.3 squared. So we're gonna have 0.3 squared plus 0.3 squared. So we really just got 0.9 plus 0.9, which will be 1.8. That's the variance. So the standard deviation of d will be the square root of 1.8. And that would be about 3 squared. Oh, sorry, not 1.8. Well, the 0.18. Oh, well. I wonder. 0.18. And I think the square root of 0.18. That's what makes all the difference. Let me fix that. Also, when I will make mistakes. And that'll be about 0.424. So let's look to see what we got going on. Let's draw a picture by what we're trying to find. So I'm going to draw a normal distribution. This will be the distribution of D. It's normal with a mean of 0 and a standard deviation of about 0.424. So this is 0. Now this is where you want to think. Well, you always got to be thinking, but this is where you really have to make sure you catch on to this. Remember, you're trying to find like what the odds of getting a difference this large or larger is. Now, this difference is just how far these values are away from each other. Remember, I just picked to do x1 minus x2. You could have done x2 minus x1 and got positive 0.8. So you're basically looking at two areas on the curve. So for example, in this case, I'm looking at, the area to the left of negative 0.8. So I want to find this probability. Find this shaded region because that's what that is. I want to find, in other words, I'm trying to find the probability that D is less than or equal to negative 0.8. That's what that is. But I also want to find the probability of the difference being greater than 0.8. Because the difference, again, can come from both ways. You can subtract x2 minus x1 and you would have this area here. The probability that D is greater than or equal to 0.8. Now I bring this up now, so when I finish the problem, you'll understand it better. Because you really just have to solve for one of these, because once you find one of them, you just double it because you have a symmetric curve. So it's not much extra work, but I definitely will have students that will miss this on their test, I guess because they forget this part. So they won't get full credit. So be careful with problems like this. Make sure you address this. And remember, drawing a picture helps. Anyways, now it just becomes a simple normal distribution problem from like chapter 2. So you find a z-score that corresponds to this. You find, the area in the normal curve. Sketch right here. Just for the review. Remember, going back to like z-score is the normal curve with a mean of 0, standard deviation of 1. So you want to find, that z1 and that z2, but you don't have to find that z2, just find z1. So find the z value that goes to negative 0.8, and using that formula, that z equals x minus the mean over the standard deviation, and we can find it. So let me go ahead, let me move this up and let me calculate it. Let me calculate it right here. So then get the whole problem. So z will be our observation value. So negative 0.8. We're looking for this, negative 0.8 minus the mean, which is 0, over standard deviation of a 0.424. And we'll get about negative 1.89. So I want to find the probability that z is less than or equal to negative 1.89. So then I look at my table A curve, table A, normal curve. Again, going back to what we did in chapter 2. So we look to the area to where z is about negative 1.89 or negative 1.9. Negative 1.89. So here we got 0.294. No, not 0.2, 0.0294. 0.0294. So this area is 0.0294. And then that means that this area is also 0.0294. So your total probability is used adding these two together. So you do 0.0294 times 2, and you're going to get 0.0588 about. And then remember to answer the problem in context and not lose track of what you're doing. So what this is saying is that the probability of getting a difference of at least 0.8 or greater is about 5.88%. So it's kind of rare, but it's not that rare, you would say. But again, make sure to answer this in context. So here we go. Let's finish the problem. So, and there's about maybe if you can leave it like that's a decimal if you want, doesn't matter. It's about 0.0588 probability. That's a 10 to observe a difference of 0.8 grams per liter, or grams per mile. Well, actually, let me we'll observe a difference of at least 0.8 grams per mile of nitrous oxide, or observe a difference of 0.8, or there's about a 0.0588 probability that the attendant will observe a difference of 0.8 or greater. In 0.8 or greater of nitrous oxide. And there we go.